Okay, welcome everyone to this video for section 2.3, talking about cylindrical shells. And here is that example 2 problem set that we didn't get to cover in class, but we're going to go over it now. So much like the other problem set from problem 2, or I'm sorry, section 2.2, these ones are a little bit different, right? We're not rotating around a X or Y axis, we're rotating around some vertical line and some horizontal line. Okay, so, but much like the other ones, just gotta graph it, draw a rectangle, rotate it, and see what happens. So luckily with these problems, we could just set it up, don't gotta evaluate it, but um, just gotta get there first. So let's graph this thing. So region bounded by parabola x squared, um, line x plus 2, rotate around vertical line x equals 3. Okay, so let's graph this thing. So we'll have um, the graph looks something like this. Okay, zoom it a bit, and we'll have the tick marks go up to, say, 1, 2, 3, 4, 5. Uh-oh. 1, 1, 2, 3, 4, and 5. Okay, so we want to go about x equals 3. Let me use a different color for that. Here's x equals 3. Didn't go so well. Here's x equals 3. Okay, well, that's fine. X equals 3. And let's just draw our graph right now. So let's sketch x squared. So basic parabola, at 0, it's going to be 0. At 1, it'll be 1. At 2, it will be 4. Okay. And -1, so a little spaced out for my liking. Kind of dial this back, erase this. And that's -1 is going to be 1. Okay. So here's that parabola, something like this. And then let's sketch this line x plus 2. I know my y-intercept is going to be 2. And I know at -1, I'll have -1. I'll have 1, sorry. And I know at 2, I will have 4. Okay. So that's our line right there. Try it again. I don't like how that looked. Okay, there we go. So that's our line there. And we have this shaded region in here. And remember, we want to use the shell method. So we have to be parashell. Okay, so our representative rectangle needs to be parallel to our vertical line x equals 3. And so we will have a vertical line or vertical rectangle dx. Okay, and we want to rotate around the vertical line x equals 3. And when we rotate shells, all we really got to do is it's a lot more easier than washers and discs. We literally just draw them out like that. But okay, so let's try this out. So it would look, maybe it's a little too far, but has to be equal in length on both sides. But okay, so that is my shell. Okay, so remember volumes of shell, they are, let me kind of go over here. So volume is going to be A to B 2 pi RH dx. So we got to find the radius and the height. Okay. So yeah, this we're rotating around x equals 3, so it's a little different this time. And so what we have to do here is figure out what the radius will be. So I guess I'll use orange. So here's a radius distance here. That's our radius, right? And what is that distance? So remember, this distance from here to here is 3. Okay. And remember that we're kind of missing this little bit of horizontal distance here. And so that distance will be some x. It always depends on whatever rectangle you choose, but that will be sort of the makeup of this. So the radius, well, we know that this whole thing is 3, and we know that x and r make up this 3. So what we'd have here is 3 equals x plus r, but we want to know what r is. So we'll have that r equals 3 minus x. Okay. So that is a radius. And now the height is just our vertical distance. And our vertical distance just depends on these two functions and where they are at that certain point in time. So since our vertical line x plus 2 is on top and our parabola x squared is on bottom, the distance is just the top minus bottom. So what I'll say here is height equals x plus 2 minus x squared. Just the distance between those two formulas. Sorry about that. Okay. So that is how we find the radius and height. So we have our values. We are rotating dot x equals 3, and we're going from -1 to 1 to 2. Sorry. Let me point out those values. So this is -1, 1, and this is 2, 1. Okay. So we have those values there. And so the volume is the integral from -1 to 2 to pi. My radius is 3 minus x. And my height is x plus 2 minus x squared and half dx. And that is our answer. We write volume. But that is our answer. Okay. So it says just set up, don't gotta integrate, but that is how we find that. Okay. So the hardest part for these is always a radius, but go ahead and check out that cheat sheet in case it helps. Okay. So here we're stayed within the same region. So we're just trying to, it's always that line minus our variable, which is x. Okay. Let's try out the next one now. So different one. So we're gonna have x equals y squared, x equals 2 minus y squared, rotating about y equals -1. So when you graph things in terms of y, it's always a little, you're kind of thinking backwards. So let's go ahead and just check out Desmos and see what this says for us. So let me get rid of this stuff. And the function is x equals y squared. Oops, delete that. Y squared. Okay. Don't know why it looks like that. Let me reboot this. Okay, let's try this again. So x equals y squared. There we go. And we have x equals 2 minus y squared. Okay, so here we go. We have this little intersection here. We have it at the point 1, 1. We have it at the point 1, -1. And we have some 0, 0 there and some 2, 0 there. But okay, so we have some key points here, so let's go ahead and graph it on in the notes. Okay, so let me draw this here. Okay, so we had the points. We're really going up to 2, ideally. So it'll be something like 1. Let me make it a little bigger. 1, 2. Here's -1. A little bigger. -1. Okay, and we have 1 up here. Okay, so some key points we had here: 0, 0, 1, 1, 1, -1, and 2, 0. Okay, so we have, I'm going to use blue for this one, and it's going to be 0, 0, 1, 1. Sorry, forgot. Tick down here, going to be -1, and then just kind of sketch that out. Okay, so that is x equals y squared. And next up is 2 minus y squared, and that is also at 1, 1, and 1, -1, but this one's at 2, 0, and we just fill that out. Okay, so here is our place here that we want to rotate. Okay, so remember we're parashell, and we need this, we want to rotate about y equals -1. So let me draw that horizontal line there. Should have did this earlier. We want to rotate around y equals -1. Okay. And so we're kind of touching it here, but we're still just using shell, so it doesn't matter too much. Okay, but we prepare shell, so we need to draw represent a rectangle parallel. So that would be dy. Okay, so let's draw the shell. Pretty easy to draw. It looks something like this. Excuse the link at the bottom. Okay, but our shell would look something like this. Okay, your height is going that way, and the radius, I'll use a different color for that. That's your radius. Okay, so our radius, we're going over the axis here, right? We want to rotate. We're rotating around y equals -1. So yeah, we're kind of touching it, but we still have all this stuff up here, and we got to get over the axis to get there. So when we got to go over the axis, it's really just a variable plus whatever you're trying to get to. So our radius in this situation would just be this horizontal distance to the axis and then +1. Horizontal distance is going to be y. Okay, so it would be radius is just y plus 1. Okay, so just like your cheat sheet, if you got to go over an axis, it'll just be that variable plus whatever you're trying to get to. Okay, so don't get too mixed up with the -1. Your radius is all about distance, and you're not really worried about negative and stuff like that. So that would be your radius, and then your height, much like the problem above, where your height is a function minus a function, you'll have that same situation here, although we are in a dy situation, and when that happens, it is right to left. So it would be your right function minus your left function, and that would be 2 minus y squared minus y squared. Okay, so your height, because you can see your height is this way, so it just depends on what those two functions are at any certain time. So the height is different color. Height will be h equals 2 minus y squared minus y squared. So that is 2 minus y squared. So height, maybe I could say like right minus left. maybe up here I could say top minus bottom. But okay. So we have everything we need. We could just set up this integral and we should be all set. So running it over a bit, but try to write this out. So volume equals the integral. We're going from y value of -1 to y value of 1. So it'll be -1 to 1, 2 pi r h dy. And so what that is just -1 to 1, 2 pi, I feel like I'm going to run out of room, 2 pi y plus 1 times 2 minus y squared dy. And that's the answer. So got it in there, but that's how we do that one. So like I said, these ones are different. You're rotating around vertical line, horizontal line. Here you got to go over the axis. Here you're not going over anything. So you can kind of see how the radiuses differ in that way, right? But here is how to do these problems. Should help you with the homework, the lab, and the online homework. So hopefully this helps. And let me know if you have any questions. Okay.